Now, even though we deal with chemical reactions basically looking in one step, when we talked about kinetics, we talked about multi-stepped reactions, but in electrochemistry, we're not only going to talk about multi-stepped reactions, but we're actually going to look at the process on the molecular level of what's going on between the molecules and between the electrons in a chemical reaction. So if you look at this top reaction, it looks fairly normal, except for the fact that obviously it's missing all of its negative ions. So the net equation for this reaction is tin 2 plus iron 3 plus yields tin 4 plus iron 2 plus. If you were to look at that as a chemical reaction, you'd think, okay, something's severely wrong here. So let's break it down into what's actually going on. So we have an oxidation and we have a reduction reaction. These are what are called half reactions. Basically what we're going to do is we are going to take this big reaction and split it into the two reactions that are actually going on. So in every oxidation reaction, we know that we are losing electrons, which means that if something's being lost in a chemical reaction, it's a product. It's going to be on the right hand side. Okay, so I'm going to put my electrons that are lost on the right hand side to indicate that that is oxidation as to what's going on. In the other reaction, obviously if one is losing, the other one must be gaining, and so the electron goes on the left-hand side. Now the thing about this is, before we were balancing reactions based on atoms, now we also have to balance reactions based on electrons. So even though there's one tin on the left and one tin on the right, our electrons actually don't balance, because you'll notice we have a 2 plus charge here and a 4 plus charge here. If we take into account the negative, we need more electrons to indicate the actual loss of charge. So this tin 2 plus to become 4 plus must actually lose 2 electrons. Now, in the case of the iron doesn't need to gain 2 electrons. It's going from 3 to 2, which is obviously a 1 gain of electrons. But because we need to balance the overall reaction, we need to actually get the number of electrons on the oxidation reaction and the reduction reaction to be equal. So since I have 2 electrons on the oxidation reaction, that means I need 2 electrons on this side too. Now if I double one, I have to double them all. So when I add this all up, the actual balanced chemical reaction that occurs in this redox situation, because my electrons cancel out from left to right, I have tin 2 plus 2 Fe3 plus yields tin 4 plus 2 Fe2 plus. So notice that in the overall reaction there's no net electrons. Okay, no electrons in the overall reaction, and that's number one. And number two is charge on the left equals the charge on the right. Notice that my charge on the left is a 2 plus 2 times a 3 plus, which is a total of 8 plus, because it's 6 plus 2 plus is 8 plus. On the right hand side, I have a 4 plus and 2 times a 2 plus, which is a 4 plus. So 4 plus 4 plus is 8 plus. So I have a plus 8 charge on this side, a plus 8 charge on that side, and they therefore are equal to each other. This is going to be key, this second fact, because in the AP reactions, they will often give you reactions that balance by atom, but they don't balance by charge, and you need to be able to recognize that the charge must be equal on both sides. So now let's balance a couple of reactions. So here's what I want you to do. I want you to practice the 3 of them on your own, pause the video, and then come back and see how I'm going to do it. So go ahead and pause right now. Okay, so now let's balance. So I'm going to split my reaction into my 2 half reactions. So I have a chlorine reaction, and I have an iodine reaction. Now you'll notice different from the first one is my atom numbers don't equal. So the first thing I always want to do is balance my atoms first. So now I have the right number of atoms. Now I can balance the charge. Well, notice that I have no charge on the left and a -2 charge on the right. And the only way that the chlorine could have become negative is if it gained 2 electrons. Notice my charges on both sides have to be equal. The opposite is going to happen on the iodine. -2 charge on the left, 0 on the right. So now my reaction, when I add them all up, and I'm going to put the balanced all up top, because now my electrons cancel out, I'll have Cl2 plus 2I minus yields 2Cl minus plus I2. Okay, now that top one balances both by charge and by atom. So sometimes it's easy to see that it needs to be balanced one way, sometimes it's not. Now let's do the second one. Again, split it into your two half reactions. Okay, luckily my atom numbers are the same here, but my charge is not. So I have a 0 on the left, I have a plus 2 on the right, and the only way to get from a 0 to a plus 2 is to lose 2 electrons. In the case of the second one, I needed to gain 1 electron. Now my electron numbers don't equal each other, so I have to make sure that both of them balance out. So in order to do that, I must multiply the second reaction by 2. Now I can see that I've got a 2 negative plus an 8 gives me a plus 6 here. This is 2 times 3 plus is plus 6. Now my electrons can cancel out, so I always do that to double check, because remember I said charge on the left has to equal the charge on the right. I'm going to make my balanced reaction up here, and again I'm going to double check. So I have a 0 plus 8 plus is a 8 plus. I have a 2 plus a 6 plus is an 8 plus charge, and so that's equal, so I know that I balanced it correctly. Now the last one. The last one's a little funky because I got 2 reactants and only 1 product. So I'm actually going to make 2 half reactions involving the same product. So process doesn't change, but notice now I've already doubled my FEs. Okay, so in order to go from 0 to plus 2, I must have lost 2 electrons. In order to go from 3 plus to 2 plus, I must have gained an electron. Again, I got to get my electrons to balance. So I double everything in my third reaction. I add it all up. This one I'm going to actually add up because it's a little bit weird. So I've got, it'll be Fe plus 2 Fe3 plus yields 3 Fe2 plus. And I'm going to double check my charges and my atoms. I've got 1 plus 3 atoms of iron on the left, 3 atoms of iron on the right. A plus 6 charge over here because I have 0 plus 6, and a plus 6 charge over there. So that means I must have done this correctly. So this bottom one is my overall reaction. So that's balancing a regular old half reaction. Now what about balancing half reactions that are not normal? What if they're in acidic mediums or basic mediums? So we're going to deal with those two right now. There's actually a process for these. The other ones, it's kind of, you got to pick and choose what you're going to do. It's a little bit trial by error. So now let's do the acidics. Okay, the first thing you do in any acidic reaction is divide your overall reaction into 2 half reactions, just like you did before. Second, balance all elements that are not hydrogen or oxygen. Okay, I'm going to show you how to balance those in a second. Third, now balance the oxygens by adding H2O to the opposite side. So whichever side has the least number of oxygens, you add water to that side. Fourth, balance the hydrogens by adding H plus, again, to the opposite side. You'll notice that these two are typically on opposite sides. In fact, they pretty much have to be in acidic reactions. It is very rare, very rare to find one that they're on the same side. Lastly, you balance the charge by adding electrons to the most positive side. Again, the electrons must balance between the 2 reactions. Okay, so a lot of it looks the same except for 2, 3, and 4, in which now all of a sudden I'm throwing in stuff that adds acid. Now, if you think about it, the H plus and the H2O makes sense because acids are primarily H plus and they're always aqueous, which means they have to be in water at all times. Okay, last step is cancel everything that's on both sides of the reaction because there's going to be a lot of duplicates, and add the whole thing up. So now let's actually try this. So I've got MnO4 minus plus C2O4 2 minus yields Mn2 plus carbon dioxide. Okay, now it's in an acidic solution. It will tell you that it's in an acidic solution. So make sure you keep an eye out for that stuff. So the first thing I do is I split it into my 2 half reactions. I have MnO4 minus yields Mn2 plus, and I have C2O4 2 minus yields CO2. Okay. Second step, balance all the atoms that aren't oxygen or hydrogen. So in my first reaction, I have 1 manganese on the left, 1 manganese on the right. So it's balanced. So I move to the next one. I have 2 C's on the left, I have 1 C on the right, so I hit the right up with a 2. Now I balance the oxygens by adding water. So I go to my first reaction. I have 4 oxygens on the left, none on the right. So I'm going to add 4 waters, okay? Because that gives me my 4 oxygens. Same thing down here. I've got 4 oxygens on the left. Oh, but look at that. I already have 4 oxygens on the right. So I don't need to do anything with relationship to the oxygens and water here. Next step, balance hydrogens by adding H+. So I look on the left, no H+ on the right, no H+ on the left, 8 H+ on the right because it's 4 times 2. So I'm going to add 8 H+ to my left-hand side to balance it out. Now I'm going to do it on the second reaction. Well, there's no hydrogens on the left and no hydrogens on the right, so I don't need to add any H+. So I skip to my second to last step. Balance my charges by adding electrons to the more positive side. On the left, I have 8 H+ plus a negative. Well, 8 minus 1 is plus 7. I have a 2 plus here, a 0 here, so I have a plus 2 here. The more positive side is obviously the left. What's the difference? 5. 7 minus 2 is 5. So I add 5 electrons. This reaction, I have a negative 2 on the left. I have a 0 on the right. 0 is more positive than negative 2, so I add 2 electrons on the right. Now I have to balance my charges between my 2 reactions. So I have 5 electrons here, 2 electrons here. Well, that's going to give me extra electrons. So I have to make sure my electrons balance. So I'm going to multiply this whole reaction by 2. So this becomes 10. This becomes 16. This is a 2. This is a 2. And this becomes an 8. I'm going to erase these other numbers so you don't get confused. This reaction, obviously, I'm going to multiply by 5. So it'll be 5. My 2 is now at 10. And my electrons are now also at 10. Cross out anything that's on both sides. So I'm going to change colors just to make this a little bit more obvious what I'm doing. Okay, so I have 10 electrons, 10 electrons. So those cancel. And that's pretty much it. In this case, nothing else cancels out. So I just add the whole thing up. 16H plus 2MnO4 minus, don't forget the charges, 5C2O4 2 minus. If you forget the charges, it's automatically wrong. 2 plus 8H2O plus 10CO2. As you can see with this, prior planning prevents poor performance. So you have to give yourself some space in order to write out these reactions. Otherwise, it's very easy to kind of run out of room at the very end. Okay, I can't reduce this down anymore because I've got a 5 here, and everything should be balanced. And sometimes, when I do this when I'm first practicing, I always double check that my charges are equal. So on the left, I have 16 plus, and 2 negative is 14, and 10 negative is minus 4. I'm sorry, it's plus 4. On the right, I've got 2 times 2 plus, which is a 4 plus, 0 and 0 plus 4. My charges are equal, so this must be balanced correctly as I did this. Okay, now, that was the one example for acidic. Now let's talk about basic. For basic balancing, I'm going to only add a 4A and a 4B. Okay, I'm going to balance the reaction exactly like I did in acidic, except that I have to get rid of the acidic situation. I have got to get rid of that acidic medium. So after I balance the reaction with the H+, I'm going to add an equal amount of OH- to both sides. That's not intense enough. To both sides of the reaction. Okay, the OH- will cancel the H+, and then an extra base to the right-hand side. Then the H+ that's being canceled with the OH- is going to form water. And literally what I do is I cross this out and I write water. So wherever that H+ and the OH- is in the reaction, I just cross them out and balance it with H2O. So let's do a very similar reaction, but let's do it now in a basic solution. So notice again, it does say basic. I'm going to change up my color just to vary things for you. This is green, so let's go with dark blue. Okay. Split them into your two half reactions. Cn minus, CnO minus, MnO4 minus, and MnO2. By the way, states of matter are not important in these reactions. Balance all the atoms that aren't oxygen or hydrogen. One carbon, one carbon. One nitrogen, one nitrogen. That's okay. One manganese, done. Balance the oxygens by adding water. So I've got one oxygen on the right, so I add water to the left. I have 4 oxygens on the left, 2 oxygens on the right, so I'm going to add 2 waters to this side. Balance my hydrogens by adding H+. I've got 2 H's on the left, and add 2 H pluses on the right. I've got 4 H's on the right, so I'm going to add 4 H pluses to the left. Now, this is where it's different because it's a basic solution. Add an equal amount of OH minus to both sides of the reaction to cancel the H plus. I have 2 H pluses here. I'm going to add 2 OH minuses plus 2 OH minuses. Good. These 2 H pluses and OH minuses become 2 H2O on the right-hand side. Okay? On this one, I'm going to add 4 OH minus to the left and 4 OH minus to the right. These two become 4 H2O. Notice how giving yourself some space is going to be really important in these. Okay, don't cancel anything yet. Remember, we've got to do the electron step first. So I've got 2 times a -1 plus a -1 is -3 on the left. I've got a -1 on the right. -1 is more positive than -3, so I add 2 electrons to the right-hand side. In this one, I've got 4 neutrals plus a -1 is a -1. I have a 0 plus a 0 plus a 4 negative is a +4. I'm sorry, it's a -4. -1 is more positive than -4 by 3, so I'm going to add 3 electrons to the left-hand side. My electrons do not balance between my 2 reactions, so I multiply the first one by 3, the second one by 2, finding that common denominator, that least common multiple, whatever it is. It's that whole math concept. I never remember those terms. So this becomes 6. This is a 3. This is a 3. This is a 3. This becomes 6. And this becomes 6. This side, this becomes 6. This becomes 8. This is a 2. Let me get rid of these other numbers in here. This is a 2. This is now a 4. And this is an 8. Okay. Now, you can do this one of 2 ways. You can add up everything, write this huge reaction, and then cancel out anything that's on both sides. Or, if you can kind of see what's happening here, we can cancel as we go, and I like to cancel as I go. Now, yes, I tend to make mistakes when I'm doing this, but it's usually not so bad. So, notice I have 6 OH minuses on the left, 8 OH minuses on the right. So these cancel, leaving me 2 behind. In this one, I have 3 waters on the left and 6 on the right, leaving me 3 behind. Okay? In this, I know my electrons are already done. They're canceled. Here, I've got 8 waters on the left, 4 waters on the right. So my 4 waters over there will cancel, leaving me 4 behind. And that's it. That's everything that needed to be canceled. So now I add everything up. Oh, and I'm sorry. Now, there's one more, and hopefully you caught this. I've got 4 waters down here and 3 waters up here, which means that these 3 waters will go away, and this 4 will actually become now a 1. Add them all up. 3Cn minus plus an H2O plus 2MnO4 minus yields 3CnO minus plus 2MnO2 plus 2OH minuses. Double check your charge. 3 times a -1 is -3 plus 0 plus a -2 is -5. 3 times a -1 plus 0 plus a 2 negative is a -5. This balances out. Basics are a little bit more complicated because there's a lot more stuff at the end of the chemical reaction when you're all done balancing. But notice it follows the same principle. Now hopefully these aren't so bad. Go to your review sheet and your homework and start practicing these to make sure you know how to do them.